Hey folks, it's Michael Johnson. Welcome to this week's Energy Sketch. Going to sketch a little bit around this article, this scientific paper that was just released a few weeks ago, Decarbonizing Canada's Energy Supply and Exports with Solar PV and E-Fuels from a group at McGill and McMaster University. So, first of all, a small disclaimer here. I have worked and I do currently work in my work with these people, these researchers, and all opinions are my own. No guarantees, no refunds. So let's get into it. If we look at the electricity production in Canada, currently about 80% of it, roughly, comes from hydro, wind, and nuclear, and the rest of it comes from fossil fuels. Now, if we wanted to decarbonize the remainder of our electricity production, what this paper shows is if you actually took a small portion of the oil sands area in Alberta and covered it with solar PV panels, we could fully decarbonize the rest of this production. Now, let me just be clear here, and this paper is very clear on this point also, that this is a high level order of magnitude estimate. It does not take into account costs, does not take into account the transmission infrastructure that would be needed to transmit all that electricity from the oil sands region out to the rest of the country to decarbonize electricity production. But it shows you the scale that is possible in a country like Canada, because whenever we think of solar in Canada, we always think, oh no, there's no sun here, it snows too much, we're too far north. Well, it's not really the case. I mean, sure, you need to install a larger area of solar PV panels in order to get the same amount of energy as if you were further south, but still, there is a huge solar energy potential in Canada. One of the other challenges that they do address here is this problem of seasonal energy storage. So we're plotting here from January to January to January, like 2 years. And you can see in our total energy demand is kind of reasonably flat, but there are peaks in the winter time for heating and other things. And that's completely inverse from the situation of solar energy, right? You get more solar energy in the summer. So the idea is that we would overbuild massively the solar energy installations. And then when the sun is shining in the summer, we take that energy and we store it like we do with logs to heat our cabins, right? We would store that energy to use it in the wintertime. And the next part of the paper talks about secondary energy. So this is things like transportation, agriculture, and industry, and how much PV we would need to install in order to convert this from fossil into either electric or e-fuels. And the third part of it is about our energy exports. So a lot of times when we talk about decarbonizing Canada, we hear about, well, all the economic benefits that we get from export of our energy and the jobs that are produced in that sector. And they show with some high level numbers how we could replace all of the oil, gas, and coal that we currently export could be replaced by e-fuels, such as metal fuels like iron and aluminum, as stored clean energy that we could export to help decarbonize other parts of the world and also generating a large number of good jobs in the decarbonized energy sector. So there are so many threads in this paper, folks. I'm going to be digging into this in the next few weeks, months, maybe enough content here for a whole year. We'll see. Of course, as always on the Energy Sketch, there's no guarantees, no refunds, but I hope it was fun. I hope you enjoyed thinking about decarbonizing Canada's electricity, secondary energy, and energy exports with clean solar power stored in various forms. And we'll get into more in the future. Thanks so much for tuning in, folks. See you next time, Monday, 12 p.m., youtube.com/@energy sketch. See you later. Toodaloo.